In today's lesson, we will look at how to convert the raw data in our frequency tables to relative frequencies, which are percentages. We will also look at the advantages of visualizing our data this way. Let's get started. In our first example, 200 people were surveyed about where they live and what kind of pet they have. On the left, our frequency table shows the results. In green, I have totaled the margins. In red, I have the grand total from the row and column, which should total the number of surveys that were given. On the right-hand side, I converted this table to percentages. Let's show how this 27% was calculated. Well, 54 people surveyed lived in an urban setting with a cat out of 200 total people surveyed. 54 divided by 200 is 0.27 or 27%. These percentages on the right-hand table are referred to as joint relative frequencies. There are two conditions that apply: the setting, urban and rural, and the type of pet, cat or dog. They are called relative frequencies because they've been converted to percentages. All the joint relative frequencies in the table should sum up to 100%, meaning we are representing 100% of the survey results as we did in the original frequency table. The major advantage for converting our frequencies to percentages is that we can now make comparisons between two or more data sets, regardless of whether they are large or small data sets. When our results are listed as numbers, we have to consider the sample size to interpret the values. We can fine-tune our percentages into conditional relative frequencies, which allows us to isolate just one condition. On the left-hand side, our location has been isolated, urban or rural. Notice the margins for each column sum to 100%. What we are saying here is that 40% of the people who live in an urban setting have a cat, so that means that 60% of urban dwellers have a dog. Similarly, 64% of the people who live in a rural setting have a cat, while 36% of those in a rural setting have a dog. Over on the right, we're isolating the cat and dog condition. Notice this time the rows add up to 100% at the margin and not the columns. This time we are saying that 56% of cat owners live in an urban setting and 44% of cat owners live in a rural setting. For dog owners, 77% live in an urban city while 23% of dog owners live in the country. Let's take a look at how this 40% conditional relative frequency was calculated. From our table above, we see that 54 people lived in an urban setting with a cat out of a total of 134 people who lived in an urban setting. If we divide 54 by 134, we get 0.40 or 40%. Let's practice converting those frequencies again. In this example, 113 people participated in a study to see if vitamin C reduced the length of their cold. There was a treatment group who received some medicine and a placebo group who received nothing. To fill in the table on the right, use the joint frequency from each cell, then divide by the total number of participants, 113. Here's what I mean. 16 out of 113 gives 14%. 17 out of 113 gives 15%. 27 out of 113 gives 24%. 53 out of 113 gives 47%. In the second part, we want to calculate the conditional relative frequencies. Part of the table is already filled in for you. On the left, we're given 37%, which is 16 out of 43. Looking back to our original data, we see this must be the conditional frequency for cold duration, 16 out of 43. We can fill in the rest of the table using those frequencies divided by the margin total at the end of that row. 43 for folks who had a shorter duration cold, less than a week, and 70 for those who had a longer duration cold, greater than or equal to 1 week. On the right, we're given 48%. This is the same as 16 out of 33. Looking back to our original data, we see 16 out of 33 must be referring to the treatment group. We can fill in the rest of the table using those frequencies divided by the margin total at the end of that column. 33 for folks who were in Group A, and 80 for people who were in Group B. The last question asks us to predict whether Group A received the treatment or Group B. We're told that the researchers expect the treatment to result in a shorter duration cold. Let's look at the evidence we have. Of those who had a longer duration cold, most were in Group B. On the other hand, of those who had a shorter duration cold, most were still in Group B. Let's look at the other side. Of those who were in Group A, slightly more, or 51%, had a longer duration cold. Of those in Group B, the results are even further skewed towards a longer duration cold, 66%. It's certainly not decisive, but it may be the case that Group A was the treatment and Group B was the placebo. This is assuming, of course, that the treatment does actually reduce the length of the cold.